This is the Convergent Science Network podcast. Leading researchers in the domain of neuroscience, brain theory, and technology are interviewed by Paul Verschure and Tony Prescott.
So, Paul Verschure here with the Barcelona Cognition Brain Technology Summer School, talking to Kevin O'Regan. Kevin, welcome.
Thank you.
And what you presented at the summer school, also very much related to your book that just came out. What's the title of your book?
The title of the book is Why Red Doesn't Sound Like a Bell, Understanding the Feel of Consciousness with Oxford University Press.
Very
you can
good.
buy it on Amazon.
Okay. But now, in some sense, in the challenge for the talk here was to say, okay, how can we build robots that feel? Right, and then sort of the problem you started out with is, okay, if we have this closing scene of, I think it was Terminator 3, where he ends up in the boiling vat with burning oil, whatever it was, would this Terminator feel pain or not? And this is in something how you start to address this whole question of feel and qualia. So what's your answer to this question, and how do you get to that answer?
So in one word, the answer is yes. In fact, Terminator would feel the pain, even though it sounds surprising at first. And I think that to understand this, you have to think about feel in a new way and realize that it's not something that is generated in some magical way by biological organisms, but it's a way of talking about the capacities that biological organisms have, just like life is a capacity or a property of the way organisms interact with the world. As soon as you have something like Terminator who interacts with the world in certain ways, then what we mean by feel is that's what he's doing. Mm-hmm. There's nothing new. You don't have to build anything into a robot for it to feel. Once it behaves in the way that we call having a feel, well, then it has a feel.
Okay, but then you run the risk that in some this is true by definition.
That's right.
Right. So this is now what we have to inspect in a bit more detail.
Mm-hmm. It is. As I was saying in my book, and as I was saying in the talk I gave today at BCBT, it's really a matter of a trick. It's a trick, a scientific trick that we can play that lets us think about things in a new way. I think that what happened with life at the beginning of the 20th century was the same trick. So what happened was the vitalists at the beginning of the 20th century thought that in order to explain how certain organisms possessed life, you had to postulate some élan vital or some vital spirit that kind of imbued life into these organisms. But gradually it became clear over the 20th century that this was the wrong way of thinking about life, and that it was a better way of thinking about life to say that life is just a word that applies to certain organisms that interact with their environment in a certain way. They can reproduce, they metabolize, they breathe, they move, and it's a matter of definition to say that whether or not an organism is alive. Is a virus alive? Is a bacterium alive? These are matters of definition. I suggest that taking the same stance with regard to feel and saying that feel is a certain way of interacting with the environment solves the problem of the magic of feel.
Mm-hmm. But you have, in that redefinition, you have actually anchored that by looking at very specific problems around this notion of qualia, right? Where you looked at, let's say, ineffability, the impossibility to communicate these states, the structure to feel, and also the presence of feel.
Right.
So what's the transition there exactly if we go to these apparently, let's say, unsolvable problem, this hard problem of qualia, which is summarized in these three key properties? How do we now resolve that if we take the sensorimotor view?
Okay, so I think classically, if you think about feel in the normal way that most people think about it as being somehow generated by the brain, it becomes rather mysterious to understand how it could be, for example, that the brain could generate the feel of redness, and that this feel would be different from the feel of greenness. How could the brain do this? What kind of neural mechanism could we envisage that would generate two different kinds of feel? Also, how could one generate a something in the brain that could make it feel like something to have the feel of redness or to have a pain rather than feeling like nothing. These are the classic problems that the philosophers put forward to when they talk about what they call the hard problem of consciousness, namely the question of why there's something it's like to have a feel. And my idea is that in order to overcome the difficulty that the philosophers have with feel, taking the stance according to which feel is a way of talking about the capacity that an organism has to interact with its environment, taking this stance allows us to solve these mysteries about feel. So my first step in my book is to try and decide what exactly the mysterious aspects are. And one of the mysterious aspects is the fact that feels are considered to be first person and ineffable, that's to say, not communicable to others. A second mystery is the fact that feels have a structure, like they can be compared and contrasted. For example, red is more similar to pink than it is to green. Sometimes they cannot be compared and contrasted. For example, red is completely uncomparable to the smell of onion or to the sound of a bell. So how do you explain these facts? That is one of the mysteries. That's the second mystery, in fact, of feel. First one is ineffability. The second one is the structure of feels. And the third mystery is really the most profound mystery, which is why feels have something it's like. Why do people say it feels like something rather than it feels like nothing? That's the question of sensory presence. And I think that if you take this new stance, this new, what I call sensorimotor approach, you can overcome those.
Mm-hmm. But now in analyzing these problems, in some sense, you're already biased by, let's say, the sensorimotor paradigm that you want to take, right? And for instance, if you look at this issue of the sensory presence, where you were making a distinction between, let's say, subconscious autonomic processes versus, let's say, sensory processes, saying, okay, these, you're not consciously aware, there's no qualia, there's no feel as such attached to the level of oxygen in your blood, right? While if you talk about indeed red or bottles or sound studios and so on, there would be some content to that. But the argument was made there that this was also Björn Merker who made that point that, well, actually in terms of the feel, right, there can be a very strong feel when oxygen levels reach a certain lower bound, right? Mm-hmm. When the sort of homeostatic regulation starts to become unstuck, there might be a very strong feel. So what does it mean then with respect to this notion of sensory presence? And is then sensory always towards the external world, or does it also include an internal world?
Right. So I think classically, even from the Greek philosophers onwards, there's always been this idea that there were 5 basic senses, hearing, seeing, tasting, smelling, and touch. And these 5 basic sense modalities, they seem to have something special about them as compared to other senses. So what you were referring to is, for example, the feeling of suffocating when I'm out of breath, or the feeling of being tired when I've got too little glucose in my blood, for example. These are perhaps also feelings, but they have somehow a different nature. They don't seem quite so present, I should say. There's less of something it's like to have them. Our everyday world is essentially composed of information or sensations we get from these 5 basic sense modalities. So what I would like to do is explain why there's something special about these. Obviously, feeling tired and feeling the feeling of suffocation, or the feeling of the posture that you're adopting when you sit, for example, or when you stand. These certainly are things you can become aware of, but whereas one feels the pain and one sees the redness, one doesn't somehow feel your posture or feel your tiredness in the same way. Well, I think it's arguable. I think one can discuss. Maybe there's a continuum. Maybe one should make a break. But
that's I think the issue, right? Would you accept a continuum?
Absolutely,
there?
Yes.
Yeah, I think it's not a critical challenge.
Absolutely
to your theory,
not.
right?
No. In fact,
in fact,
No, in fact, I would like to explain all the aspects
Right.
of the continuum. I'd like to explain, well, why is it that the philosophers for centuries have distinguished these 5 sensory modalities as being somehow different and somehow special?
Mhm.
I would have to account for that in my approach.
Exactly. Right. So, but now there are 2 steps we have to make, right? So on the one hand, if you look at the state of the art in the field, when we deal with qualia from a scientific perspective, not necessarily a philosophical one, you would say, okay, so now we're going to look for neural correlates, right? We're going to have people experience different things. We're going to try to control this in some way. When people report whether they experience certain things. And now we're going to look at what neurons are doing in relation to these kinds of experiences. So why is that not helping us?
So that would certainly be the first impulse of the average scientist today, would be to look for the neural correlates. And so supposing they were to find that neurons that were strongly correlated with a sensation of red were these neurons, and the neurons that were strongly correlated with a sensation of green were those neurons. And this was true in every human being, and it was just 100% correlation. And then we could ask, well, what is it about those red conveying neurons that gives that red feel rather than the green feel? And we could look into the neurons, and maybe we would find that it was a special neurotransmitter, for example, that the red neurons had that the green neurons didn't have. And then you could ask, well, what is it about the neurotransmitter in the red neurons that gives that red feeling? And you could say, well, maybe it's because they have an extra nitrogen atom or something. And whatever you do, there's always going to be another question. Whatever answer you give to the question, well, why does it give the red feeling rather than the green feeling? There's always going to be another question. Mm-hmm. So I think there's a logical barrier here. There's what the philosophers called an explanatory gap, because it just doesn't seem possible. This is a logical question. It doesn't seem to be logically possible to make to bridge this gap between a description in terms of neurophysiological parameters and a description in terms of parameters that will explain the redness of red.
Mm-hmm. Right. So it's also on those grounds you say, look, throwing more, let's say, measurements at the problem will not solve the problem. We have to really jump out of this box and find a new box, right? And the key thing is that the neural correlate approach would give you this infinite regress. So it's like an underconstrained approach to this issue of subjective experience. But now, what is this alternative? How do we resolve this issue? How are we going to solve this hard problem?
So this is the trick that I'm suggesting.
Exactly.
And it's a trick, as I said, similar to the trick that was used to solve the problem of life. Mm-hmm. Now, you might say, or some people might say, well, we still haven't solved the problem of life because life is a wonderful poetic thing. And obviously what life really is something that's much richer than, DNA replication, all the stuff we know and have learned over the last century, since Crick and Watson discovered the double helix. Mm-hmm. All this is very interesting, but it isn't really life, is it? And I would counter to that, and I say it may not give you a good description of the poetry of life, but it is pretty good science that's been done. And what I suggest is that we should adopt the same tactic as regards feel.
Mm-hmm. So are you with that saying that life as such, in the traditional sense, is not a natural category? It's not really a natural phenomenon that we can nail down in reality? And the same thing holds for the qualia?
The term natural quality. What did you say? A natural
phenomenon. It's like this cup is a natural phenomenon because not only can I touch it, but I can make, let's say, objective measurements about it. And if given that, I can have some, let's say, belief that this is actually a physical object in the world that exists in and of itself, without needing further subjective experience.
I think in science there are concepts that are like the cup, which are things. And there are other concepts which are more abstract, like, for example, the concept of force. The concept of force, the concept of pressure, the concept of predator, for example. These are ideas or abstractions that are very useful to do science with, but you can't really say that they are real things. They're defined in functional terms. And I think life is best defined in those functional terms rather than being considered a thing like a cup.
Right, exactly. And the same then holds for qualia.
Yeah.
And so, but then, so now what is your trick? So what's this redefinition that would also help us in overcome these three fundamental problems you pointed out earlier?
So the trick is to suggest that when we try and understand what we really mean by having a feel, what we really mean is that we are currently interacting with the world in a certain way. So let me take the analogy of softness. If you were a neurophysiologist, you might go looking in the brain for a neuron that generates that softness feel. And I'm suggesting the following trick. I suggest that if you think about what softness really means, take the example of a sponge. The softness of a sponge is not a thing that's generated in the brain. The softness of a sponge is a way that the sponge behaves when you press on it. A sponge is soft when, if you press on it, it squishes under your pressure. So the softness is actually nowhere to be found. Softness is an abstraction. And the feeling softness means that you are currently engaged in an interaction with a sponge that obeys the laws of softness. So this is why I call my approach the sensorimotor approach. It's sensorimotor because we have motor actions, namely pressing on the sponge, and we have sensory input, namely the squishiness, the fact that the sponge seeds under my pressure. And the law, the sensorimotor law that's obeyed is the law that describes the softness.
Mm-hmm. So the key thing is that we have, let's say, a closed loop now between an agent and its environment. And this loop is regulated by certain, let's say, irreducible properties. These are the laws you would have in mind.
Why'd you say irreducible?
Well, if let's say the law is let's say a fundamental building block to maintain this dynamic relation, or it describes an irreducible component of that interaction, like the squishiness of the sponge, would then not be reducible any further. You cannot go below that squishiness to deal with feel.
No, I'm not following you. I think that the softness of the sponge is a fact about the way you can interact with a sponge.
Mm-hmm.
I wouldn't say it's somehow irreducible. I would say it's just one law that describes possible ways of interacting with sponges.
Yeah, but isn't the field tied to a certain level of that interaction? For instance, if I'm squeezing this sponge, that means I'm generating forces with my fingers. I have sensation of pressure on my fingertips and of texture on my fingerprints in correlation with this force that I generate. Right. And it's this whole correlated set of actions and reactions and sensory states that now give me my feel.
I wouldn't say they give the feel. They constitute the feel.
Yes, that are the feel. But if I would now go to a lower level of description, where I say, well, okay, it's this set of muscle synergies that is moving this one finger, that is irrelevant. That is not part of the sensorimotor law that defines the feel. So that's what I meant with irreducible. Below a certain level of description of that law, you don't gain information about the feel.
Yeah, I think the word irreducible is a bit odd there. I would rather say that the softness is an abstraction. It's a sort of what the mathematicians might call an equivalence class. That's to say, whether you squish it with this finger or that finger, whether you have these muscle groups or those muscle groups that are involved, it doesn't matter because the concept just requires something more abstract to hold, namely the fact that when you exert pressure, it seeds under the pressure. So it's a sort of higher level description of all sorts of stuff that's happening at the lower level and all sorts of stuff that's happening at the neurophysiological level that could be instantiated in a different way. For example, it could be a robot with some mechanical gripper, okay, or it could be, another animal rather than a human. And in all these cases, you could still apply the same description. The problem with the notion of a sensorimotor law is that there are many different levels that you could describe this law. Like, as you say, the pressure could be measured on this finger or on that finger. And so there's a bit of ambiguity there as to exactly where you want to put the level of description.
Right.
But
But couldn't you say that what you now call the sensorimotor law is like, let's say, the subjective component of an affordance? Would you buy that? Would that be reasonable? Or is this a completely different ballpark?
So, yeah, I mean, this sensorimotor theory has often been compared to Gibson's
Right, exactly.
notion of affordance. And there certainly is a link there, because Gibson's idea of affordance is a relation between sensory input and possible motor output. But Gibson didn't think about the impact of this notion of affordance for the philosophical problem of understanding feel and qualia and sensations.
Right.
But essentially, I mean, one could say it's perhaps the same notion, although I would like to take it at an even deeper level. I don't think, for example, Gibson would have thought that redness is an affordance.
Mm-hmm.
Whereas I would really want to claim that the feel of red is a way of interacting with red things. And I don't think Gibson would have gone so far with his notion of affordance.
Sure, that's true. But you do agree that at some conceptual level, they can be seen as complementary notions.
So, well, they're certainly related, I should say. I don't know, they're complementary.
But there's an interesting consequence if we would follow that up, because in the affordance case, it means the object intrinsically affords, let's say, a large number of potential actions.
Mm-hmm.
So in some sense, it means the sponge might also then possibly lead to a potential of possible feels, as opposed to only one. Right? And I think this might be an interesting consequence of tying these two things together.
There's a relation there.
Yeah.
There's a relation there. But so, as you say, the sponge affords a number of different actions that you can do with it. But I think Gibson, how would Gibson have, what would Gibson have said? He would have used this as a way of describing your perception of the sponge as an object.
Mm-hmm. No, right, sure.
Whereas I am trying to understand let's say the perception of the sponge as a tactile object. Okay. Whereas what I am trying to characterize is the feel itself, the raw. I would say somehow the raw feel.
Right.
So I'm not sure exactly what the link. There clearly is some kind of link there.
Yeah, but why I was probing there was to see whether there was another way to think about what you call this sensorimotor law.
Yeah.
Right? Because a law has, again, its own limitations as a construct. So maybe affordance, which seems to describe more really the intrinsic properties of objects, could maybe give us an alternative route into this understanding of sensorimotor relationships as defining feel. But now that we have, so this is the trick in some sense, right? This is the trick, and now the trick is on the table. But that then means that now you have the challenge to show how this trick solves these three problems.
Yeah.
Right? So of the incommunicability of feel,
the structure,
and the presence.
Yeah, exactly.
So can you do that?
Okay, so let's take the ineffability, the non-communicability. If you think about, say, the softness of a sponge, it's hard to really describe in detail exactly what each of the individual muscle movements you make is when you squish the sponge. It's hard to know exactly which fingers you're using, and even at a neurophysiological level, it's hard to say exactly which muscle groups are involved and so on. And so, whereas you can say there's an abstract description of what's going on, the real nitty-gritty of what is going on is something that escapes your cognitive access. It's not something that you are aware of. So it's clear that while you know that the sponge is squishy and soft, you can only explain why you know this to a certain extent. So it makes sense that softness is something ineffable. And so my claim would be that if I were able to use this way of thinking about all feels, not just softness, but red, say, that I could and conceive of all feels as being sensorimotor skills, then it's clear that the ineffability would fall out of this, because it's very natural that when you're engaged in a skill, you cannot describe in detail all the things you do when you engage in the skill.
Mm-hmm.
It's like whistling. You can whistle perfectly well, but if I asked you exactly what position your tongue is in and how you move it around to get a high note or a low note, you probably just don't know.
Right. But now, so somebody is saying, well, now I can implicitly communicate the feel because I have an operational definition. I can just look at what the other person is doing. I can sort of now, if I see you squeeze this sponge, in some sense, I can now start to relate to your feel, because I could take it away from you and I could squeeze it myself and get a sense of what that feel would be for you. Mm-hmm. Is that a reasonable interpretation of how you would solve this?
Well, that's not part of, that is something, what you said there is more to do with kind of empathy and how I can understand other people's feels.
Well, it's an expressibility, because I ask you, how does it feel? You can say, well, here, take it yourself, squeeze it. That's how it feels, right?
I see what you mean, yeah. Mm-mm. But certainly the ineffability sort of falls out from this, from the idea that the feel itself is an abstraction, and it's referring to a whole lot of nitty-gritty, low-level stuff, which you just cognitively don't have access to.
Right, but so that's one view on it. So in some sense, you say, well, ineffability, we should just accept, in some sense, right? You're saying, look, there are all these low-level processes, they don't enter consciousness, so ineffability is just a result of that, and it's not a problem.
And the low-level processes, they participate in the feel that you have.
Sure.
Okay, because if they were to change, it would be you would feel them differently. So when you squish a sponge, you invoke certain muscle groups. When I squish a sponge, I invoke other muscle groups. And if suddenly, magically, your or my muscle groups were somehow interchanged, the softness would feel different to each of us, probably. Right. Okay, but that is at a much lower level. And
right. No, but you're just saying, look, the ineffability should be understood in terms of the constituent processes, right? Because I have all these nitty-gritty processes that are part of the squeezing actions and the sensations that it triggers. These all feed into the feel, and the feel I can experience, but not these constituent processes, right? So that's why we should just accept this ineffability.
I don't know if it's true to say you don't feel the constituent processes.
Well, you will not feel, let's say, every single muscle contraction and so on, right? Or
you're not aware of them. But I think that with practice, there are these contortionist kind of people who can twitch individual muscles, and yogi type people, they have very exquisite control of certain muscles, and they perhaps can, in such cases, modulate the fields, become more diverse. So
that would be a testable prediction, actually.
Yeah.
That would mean that the feel of a contortionist, of, let's say, curled around the chair, would be
somehow more rich.
Exactly.
Yeah. So I think this deals with the ineffability, but I think the real mystery that approaches, that faces neurophysiologists is the second mystery, which is the mystery of
the structure.
The structure.
But before we go to the structure, I wanted to test this idea that ineffability. You're saying, look, ineffability is just an intrinsic property of fields, because it is like a multi-layered phenomenon, if I understand it correctly.
Yeah.
But now I could say, but there's something interesting that you're doing, because you define the field as a sensorimotor operation. I can actually see it. When you now experience drinking water, I can see you hold the cup and pour the water in your mouth.
Yeah.
So in that sense, there is a communicable aspect to your field, because I can now observe what you do. And I could engage, let's say, my mirroring mechanisms to interpret it. I could try it myself and see what it feels like and so on. So it's interesting that although you say, okay, it's just intrinsic, the ineffability, on the other hand, by defining it in these operational sensorimotor terms, it becomes communicable to some extent.
Yeah.
Would you buy that, or that's completely irrelevant?
To the sense that we both have a word for softness, say.
Exactly.
And to the extent that you have experienced the softness using your motor groups and your fingers and so on, and I have experienced the softness using my motor groups and my fingertips.
Right.
When you see me squish the sponge, you can associate that, or you can make a link between how you do it. So it's communicable to a certain extent. But of course, the real underlying feel that you have and the real underlying feel that I have are perhaps different to the extent that the neural...
Of course, that problem remains, but at least it's not a completely closed domain.
Yeah.
I have a way in with its limitations.
Yeah.
There's internal ineffability, but there's actually externally more of an openness now to access qualia.
But why do you think in other alternative in views alternative to mine, this was not the case?
Well, in an alternative view, in your case, you would always insist on saying whatever the field is, it is expressed in this sensorimotor loop of the world, right? Well, that means overt behavior. In an alternative view, qualia are very much experiential states. Let's look at wound or something. And you would say, well, we should just rely on introspection. People have to report to me because I have no access. You're saying I have access because I can look at the sensorimotor loops.
Because there is an objective.
There's an overt expression.
Okay.
Right? This would be a consequence. And I think also a contrast between
that's true.
These two approaches.
You're right. In my case, there always has to be ultimately an objective description in terms of visible behavior that you yourself can observe and therefore that others can observe.
Exactly. Yeah. So that means the interpersonal ineffability problem, which is part of the hard problem as well,
is perhaps slightly less hard.
You partially you don't solve it, but you partially overcome it. You reduce its significance.
Maybe you're right about that.
That's interesting.
Okay.
So now, so the second point was the structure, right? The structure of the field.
So how do you explain why, for example, red can be compared to other colors, but it cannot be compared to the smell of onion, for example? If you have a physiological approach, then you'd say, well, there are these neurons in the brain that deal with color, and those neurons in the brain that are to do with smells, and they produce completely different sensations, and they just can't be compared. And I say, well, why? Why do they produce completely different sensations? And you're back to an infinite regress of possible questions about why this type of neurotransmitter or this type of oscillation would produce smells rather than colors. Whereas in the sensorimotor approach, you solve the problem because the description you use to describe the feel of red or the smell of onion must be couched in terms of a language that is, as we were just saying, is objectively measurable and corresponds to motions you can do in your environment, changes in the incoming sensory information as a function of these motions, and it is potentially objectively describable in a physicist's terms. And so, for example, in the case of softness, let's just take the example, say, of feeling softness and hardness. Clearly, there's a link because something that is soft, you squish it and it seeds under your pressure, whereas if it's hard, you squish it and it doesn't seed under your pressure. So there, we seem to have a linear dimension going from things that seed under your pressure and things that don't seed under your pressure. So in the language of a physicist, or the language of objective observation, I can clearly see why it is that softness should have a linear dimension going from very soft to very hard. But if we were arguing in terms of neurophysiological excitations, saying, for example, that softness corresponds to a low activation of some neural group and hardness corresponds to high activation, it's just not obvious why it should be that way around rather than the other way around. So we're back into the infinite regress. Mm-hmm. So I'm with this view, with the sensorimotor view, it becomes clear how to make the link between dimensions of sensory experience and objective sensorimotor laws. And we can also explain why, for example, certain sensations cannot be compared among themselves. So, for example, if I compare the softness feel to the feel of whistling, there's not much you can say about the objective sensorimotor laws involved. And so it seems natural that there should be no real possible comparison between the two. Mm-hmm. Just as there's no possible real comparison between the redness of red and the smell of an onion.
Mm-hmm. Yeah, but aren't you in some sense saying, look, well, structure is not a problem because there is no common framework for structure beyond then the sensorimotor laws that I can use to describe feel?
Sorry, there's no common framework?
You seem to throw away a little bit this notion of structure, right? Because you say, look, I can scale this in different ways, and it's something that doesn't give me information on what the feel is, because the only information I really have access to is this sensorimotor law, right? So I feel, so your criticism of structure was really to say, look, there is no, let's say, common frame of reference, right? If you look at different kinds of feel across different modalities, for instance.
Yeah.
So that's, or I should just your example of intensity and its neural correlates. Well, it could go up or down with respect to intensity in the auditory domain. Either way, right? It doesn't answer the structure of the feel.
The neural representation is just a code, and there's no reason why this type of code should correspond to loud sounds rather than soft. Yeah.
So the structure of the feel does not map into a straightforward way into some sort of the organization of the structure that might give rise to it.
The neural,
neural structure.
If we're trying to make a neural explanation, we would have these difficulties because there's no way of mapping the structure of sensory experience to neural structures.
Exactly. So now you're saying, or the logic would then be that you say, well, but the structure of feel does map onto the structure of sensorimotor interaction, the sensorimotor laws.
Right. I'm saying there's a better chance of making this link.
Can you give me an example of that mapping and how it can capture that structure?
So for example, that was what I was trying to do with softness, and I was saying, well, I can explain I can explain why soft things feel soft rather than feeling hard. Okay. And there's a linear dimension going from soft to hard, and I can explain why it's that way rather than being the other way around. Because what we mean by something being soft is that it seeds under your pressure, whereas what you mean by something being hard is that it does not seed under your pressure. So
if I'm arthritic and I have difficulties to close my fingers with a certain speed, I would experience a sponge as being more hard.
Perhaps, yes.
That would be the prediction.
Yeah. If you had not yet adapted, if you suddenly became arthritic, perhaps over time when you adapt to the fact that you're arthritic. Yeah.
But then, could you predict the structure of feel from the structure of the sensorimotor interactions?
Well, that would have to be my prediction, exactly my hypothesis. I would have to.
Can you give an example?
Well, softness.
But for instance, you also talked about, let's say, color, for instance, right?
Yeah.
So don't your studies in the psychophysics of color perception give you a second example of how structure of sensorimotor interaction maps onto feel?
Right. So color, of course, is the philosopher's prototype of a feel, and so the most important thing for my theory to do is to apply it to color. If I could really explain the redness of red, that would be a real victory for my approach. And although it does seem rather surprising to think about color in terms of sensorimotor laws, in terms of things you do, taking this approach has given me some interesting insights. And I have a paper with a mathematician, David Filipona is his name, paper in visual neuroscience, something like that, where I suggest taking the sensorimotor approach to color, and I'm able to make some really interesting predictions about the redness of red, and which are very surprising. So the idea is that instead of thinking of color as something that just comes into your eyes and creates a sensation by generating the feel of red somehow, the idea is to say that what you mean by the redness of red is a law that describes the way you interact with red things.
Right.
And so what might such a law be? Such a law might be the fact that, for example, when you take a red surface and you move it around under different lights, the light coming into your eye changes in certain predictable ways. And what we were able to do, very surprisingly, is show that certain surfaces, the laws that they obey, are very particular. And in particular, red and green and blue and yellow are surfaces whose laws of behavior when you move them around under different lights are particularly simple. So this explains why red, yellow, green, and blue are what are often called focal colors or basic colors. This is something that you might think is predicted by neurophysiology, because a lot of neurophysiologists would say, yes, well, we know already that there is a blue-green system in the retina and a blue-yellow system and a red-green system, as well as a black-white system in the neural pathways. And so obviously it makes sense to think that red, yellow, green, and blue should somehow be special colors because you have these special systems in the brain. But it turns out if you look in detail at the excitation of the blue-green, the blue, yellow, and red-green systems, when they are maximally activated in the blue direction or in the red direction or the green or the yellow direction, these are not the cases when you actually see blue, green, red, and yellow. So the neurophysiology does not actually coincide with the sensation.
But then I could say maybe the channels are mislabeled.
Yeah.
Some other combination of activity that will give you then these phenomenal experience of color.
And that is indeed what color scientists do. The colors that are considered to be pure are what color scientists call unique hues. And they go around measuring unique hues. And they have been trying over the last decades to understand what combinations of the known neurophysiological color channels should be used in order to generate the unique hues that are observed. And they have, in order to accurately generate the predictions for unique red, green, blue, and yellow, you have to have complicated nonlinear combinations of the cone excitations. Mm-hmm. So obviously it's going to be possible by making some nonlinear combination to predict unique hues, but you have no a priori reason to do so. And the question is, well, why is it this combination rather than that combination that gives you those unique hues? Whereas I'm actually able, with David Philippodin in our paper, we're actually able to predict the unique hues without any parameter adjustments, without any appeal to nonlinear combinations of neurophysiological channels. Our paper actually shows precise prediction of unique hues without any such arbitrary parameter fitting.
Right. But now, if we talk about the experience of color, and we try to relate that to this notion of the sensorimotor contingencies that you're exposed to, does it mean that I only experience color when I actually am moving my eyes?
Oh, so that's a fundamental misconception. When people hear me talk and read my theory, a lot of people think that it just can't be true because obviously you can see colors without moving. Obviously you can perceive without moving. And that would be to misunderstand completely the theory. Because the theory doesn't say you have to perceive you don't have to move in order to perceive. The theory says you have to have at some time in your life moved in order to perceive. Because in order to perceive the sensory input you're getting at a particular moment, you have to be able to categorize it as being part of some sensory motor law that you have previously experienced. So it suffices to have learnt the laws previously, and then when you get a sensory input that is compatible with one of the laws, well, then you identify it as being as corresponding to that law, and so what you perceive corresponds to that particular law.
Okay. So that would mean that a fully immobilized advanced perceptual agent with immobilized eyes from the moment of birth would not be able to develop color vision or the feel of color.
I think if it were in a totally static world also, I think it would not develop the notion of color as we know it, because for us, what we mean by red is a surface that behaves in certain ways under different lights. Mm-hmm. But if you're not able to move at all and the world doesn't move, then red surfaces can reflect different lights into your eye depending on what light is illuminating the red surface. You illuminate a red surface with purely blue light, then the light coming into your eye is blue and not red. And an agent that had never moved and could not move and whose environment never changed would perceive it as blue and not red.
Right. Would your alternative also consider the possibility that not all movements have to be overt, but they can be like virtual? That, let's say, I inspect a visual scene by internally moving, let's say, a spotlight of attention without really relying on eye movements.
Well, actually, I mean, no, I wouldn't say that. I would say that what we mean by perceiving red really requires us to actually have moved at some time, and previously, and to associate the incoming sensory input with what we know about the laws that had previously occurred. I don't want to use virtual movements at all in this theory.
Okay.
Because I really think that what we mean by sensory perception involves real motion.
But then also combined with memory.
Oh, yes.
Yeah?
Prior knowledge. Yeah.
Exactly. Okay, so then, so now we have an idea of structure. So how about the presence of these sensorimotor contingencies or feel?
Okay, so the real what is it like of a sensory experience is really what the philosophers think is the great mystery. Why some things have something it's like, whereas other sensations, other sensory inputs don't have anything it's like. Like, for example, vestibular input or glucose level or oxygen level in my blood. I don't feel them in the same sense as I feel the redness of red. This is perhaps the great mystery of consciousness. And I think the sensorimotor approach provides an answer in the following way. So the idea is, let's think about what we really mean when we say that there's something it's like to have a feel. And of course, when we think about what we mean by it, we want, in the sensorimotor approach, we have to think about it in terms of the sensorimotor interaction with the environment that's involved. So if you really ask yourself why there's something it's like to squish a sponge, whereas there's no similar sensory presence to sponge squishing when you're thinking about it. So if I'm thinking about squishing a sponge, there's nothing much it's like. It doesn't have the same sensory presence as when I'm actually doing it. So why is this? And the answer is that when I'm really squishing the sponge, well, I really am moving. I really am engaged with it. So what does this mean? It means that my body is involved in this motion. It means that the changes that I affect in my motor activity create immediate consequences on the sensory input. Whereas if I'm thinking about sponge squishing, I can think as much as I like. It doesn't actually change the sensory input coming into my fingertips. So really what characterizes my real interaction with the world is the fact that making bodily motions changes the sensory input. That's one thing that distinguishes real sensory input from imagined sensory input, or from thoughts or hallucinations, for example.
However, there is this literature on the effect of imagery on peripheral aspects of the nervous system, where you might see that, let's say, the imagery of certain actions might lead to excitability of motor neurons in the spinal cord. So it's not that. So in some sense, these higher level top-down processes can percolate into the periphery, but that you would then exclude as, let's say, a substitute of such a sensorimotor contingency. It has to really be at the sensory front end.
I think yes. I think that what really characterizes a sensory interaction with the world, one of the things that characterizes it, is what I call bodyliness, namely the fact that when you move your body, there's a dramatic change in the sensory input. And even if, as you say, when you're imagining things, it may change the nature of your sensory receptors, for example, that is not a test of reality. It's not a real test of reality. A real test of reality is, well, when you really do move, that things change.
Okay.
In fact, I think, you can think about dreaming. How do you know that you're dreaming rather than that you're not dreaming? Well, what you do is, in your dream, you say to yourself, well, I'm going to turn on the light. And if the light really does turn on, then you're likely not dreaming. But if the light doesn't turn on, well, then you are dreaming. So it's a kind of bodyliness is a reality test.
Okay, but then are you saying that imagined states have no feel, or imagined states have a reduced feel by virtue of accessing memory?
Imagined states have less sensory presence.
Okay. But then you also have this grabbiness, and you have bodiness, and you have insubordinateness.
Right.
Right? So what does it actually really mean?
Okay, so I have 4 concepts that I invoke in order to characterize what it is like of real interactions, sensory interactions with the world. The one that I just mentioned is bodyliness, the fact that sensory input changes dramatically when you move your body. Another thing that's really important is, another thing that's perhaps not quite so important is what I call insubordinateness, which is that even though it's true that sensory input changes systematically and dramatically when I move my body around, there can be changes in sensory input when I don't move my body around. So the world is insubordinateness. Like a mouse can run across the floor and change sensory input coming into my eyes without me moving my body. So the external world imposes itself upon my sensors because it has a life of its own. So it's not me that is completely controlling it through my bodyliness. Although my body motions do create a very strongly correlated change in sensory input, it is not totally subordinate to my body motions because the world has a life of its own and it can create some input that is independent of my bodily motions. So that's insubordinateness. It's another characteristic. And for example, proprioception does not have this insubordinateness. So that's one reason why I think we don't feel our proprioception. Proprioceptive sensors are very rich sensory input to our brains, and yet we don't consider them to be a sensory modality in the same sense as touch. Why is this? And I think the reason is that whereas proprioception has a high degree of bodyliness in that whenever I move, proprioceptive input is systematically correlated. So has high bodyliness, but it doesn't have any insubordinateness because it doesn't have a life of its own. Proprioception is determined completely by my voluntary motions. So you don't, having just bodyliness is not enough to characterize real information coming from the outside world.
Right.
And then there's grabbiness.
Yes.
So grabbiness is another fact about our sensory systems. It is the fact that when some sudden event occurs in the visual field or in the auditory canal, my attention is immediately and incontrovertibly diverted to this, and my cognitive resources are attracted to this. And I think low-level sensory systems are hardwired up in the brain so as to interfere with cognitive processes and cause attention to be oriented towards them. And this, I think, this grabbiness, this ability to capture our attention is a particularity of the 5 main sensory modalities, which is not possessed by other sensory input. Like the glucose level in my blood, for example, can change dramatically, and it doesn't kind of stop me thinking. It may make me lose consciousness, okay? But that stops me thinking in a rather indirect way. Whereas seeing a flash of light or hearing a loud sound causes my attention to go to the loud sound or the light and process it. Whereas the glucose level isn't connected to my higher level cognitive processing in the same way. So that's grabbiness.
Okay, but would you exclude that cognitive states can have grabbiness?
Aha. Yeah, so you might think of painful thoughts, for example, or obsessive thoughts. And indeed, I think it's true that once thoughts get to be so grabby that you cannot prevent yourself from orienting your attention towards them, that at that stage, people begin to say that thoughts have a feel. But if I ask you to think about red, I don't think that you would say that it has the same kind of feel as real red when you're looking at real red has.
But still, if a thought can have this grabbiness without a direct sensorimotor contingency that it pertains to, how do you account for it?
Well, I think that it'll be an experience of a different type. It won't be a sensory experience. It will be an experience, but it won't have the same kind of sensory presence as do the experiences deriving from the 5 sensory modalities. But a presence
nevertheless.
It might have what you call a presence, given that it has this grabbiness,
But by virtue of memory again, or by virtue of something else?
That's an interesting question. Yes, I don't know. I think that I would imagine that as in the case of feels for red or for softness, your prior knowledge of having previously been engaging in the environment in this particular way, and the fact that you have cognitively characterized that as being an experience of what you call red or an experience of what you call soft, those facts, in other words, that prior knowledge and memory, play a role in categorizing your experiences. So in the same way, if you're having a thought experience, like a painful thought that you have previously had, and categorized as such, that undoubtedly that will also play a role in determining the nature of that experience. Why not?
Right. And for instance, I might feel right now extremely jealous because of your beautiful sandals. So would this emotion of jealousy have grabbiness in the same way?
Yeah, well, now emotions is something that I really haven't thought about very much. I think that, Damasio and Ledoux, for example, have written a lot about emotions, and they talk about how the bodily functions are activated and when you have these emotions, and I think those really are bodily functions related to visceral functioning, indeed, that are modified when you have these emotions. So your jealousy may make you sweat, or make your heart beat, or make you flush, or something. And the question is, what is the feel of this jealousy? How could you describe it? And so my approach, I haven't really looked at it in detail, but I don't see why my sensorimotor type approach could not also apply to emotions like this. I think essentially what I would want to say is that the trick that I've used to get rid of the philosophical problem of qualia in understanding a sensory experience is a trick of stopping reification. That's to say, of no longer looking in the brain for something that generates the experience. And I think that would be the key to approaching the problem of emotions also. So instead of saying that something generates the jealousy or something generates the fear, what I would say is what we mean by fear is a mode of interaction with our environment. It means that we are in a state where we are ready to run, or our bodies have gone into a different mode of functioning where our hearts are beating faster, and maybe our viscera have slowed down their functioning, and the experience of fear is just constituted by all those things. And to search for something that generates the experience would be the same kind of philosophical error that has been previously made for life and for feel.
Right, I understand. But now, isn't there a risk that by taking this very operational stance, in the end, you always have to bring it back to some sensorimotor contingency that exists between the agent and the environment at some point in time. So everything has to be reduced to that. Don't you run the risk of ending up in the same position as, let's say, the behaviorists that in some way wanted to minimize the role of internal states beyond, let's say, reflexes, sensor states and reactions to these sensor states. But in the end, it actually became a very complicated story that collapsed under its own complexity, because in the end, you started to talk about internalized sensorimotor or reflex loops,
right.
And it was really difficult to keep this coherent with respect to, let's say, the whole domain of animal learning.
Right.
So isn't that also a risk for this approach you take now? Because also you are committing yourself to take a look at the emotions, right? You have to go to this somatic interpretation of emotions to get the bodiliness in it, that you can bring it back to sensorimotor contingencies. But alternative views in emotion, and of course we don't really know what the truth is, but an alternative view might be, look, there are just intrinsic systems in the nervous system completely dedicated to this kind of behavioral or the emotional expression, the emotional experience, and also the regulation of different components of the nervous system using these emotional states. So aren't you putting yourself too much in this corner of having to redefine everything in sensorimotor terms, leaving little space for, let's say, additional phenomena to still exist as part of the phenomena we want to explain? Okay,
so your question, I think, really can be decomposed into two parts. The first part is what I've been talking about just a modernized form of behaviorism? First question. And second question is, how do I deal with emotions? And So I think with regard to behaviorism, I think a lot of readers of my papers have thought that this is just another glorified version of behaviorism. But that would be a terrible error, because I really think that cognitive processing and attention, for example, are really important in my theory. There are indeed the sensorimotor loops involved in squishing the sponge. You have low-level loops that are doing the control of your sponge squishing, and maybe you have low-level stimulus response behaviorist type loops that are going on there. But then I additionally suggest that there is a higher cognitive level which looks down on what's going on at the lower level and categorizes it as the notion of softness. So the cognitive part looks down on the sensorimotor loop and says, that's what I'm going to call softness.
Mm-hmm.
And the experience derives from both going on at the same time. You only have the experience of softness if you are both engaged in squishing the sponge and attending to the fact that you are so engaged.
Okay.
So it's not behaviorism, because there's this important cognitive component that is categorizing and classifying and becoming aware and attending to the presence of this engagement with the environment. And as regards emotions, so you said maybe am I not evacuating a possible additional non-sensorimotor type
exactly source of feel, right?
Source that might be generating the feel somehow. But my intuition, but I haven't thought about emotions enough. My intuition would be to take that stance would be again to making the error of reification. And why not go the whole hog, go the whole way, and just use the same approach again with regard to emotion and say, well, no, nothing is. It's a philosophical error. It's what the philosophers call a category error, to try and look for something that generates emotions. Emotions are not generated by neural mechanisms. No, emotions are just ways of interacting with the environment. It's not like the feel of red, which is one way of interacting. It's like it's the way you interact when you are afraid constitutes the emotion of fear.
Right.
So it's playing the scientific trick again of de-reifying what we mean by an emotion and giving up essentially the search for something that generates it in the brain and just saying, well, what we mean by fear is this way of interacting with the world.
But now,
and there need be nothing sensorimotor about it. Okay, the motor aspect that I invoke to explain sensations like hearing, seeing, touch, taste, and smell. The reason I have the motor component there is because these are exteroceptive senses. They are senses that that have the quality of being outside the body, and it's really motion of your body which determines what your body is. And so that's why motion is important. Perhaps for emotions, rather than these exteroceptive senses, perhaps the body motion is less important, and you could have a theory which was not a sensorimotor theory, but which nevertheless abandoned the error of reification.
Right. No, so with the reification, for instance, there are people who argue, look, the thalamocortical system is a fundamental component to, let's say, feel, right? Because if we have patients with lesions to their, let's say, interlaminar nuclei, they lose consciousness. There's no more feel. They're like zombies, right? So, in some sense, I could say, well, I could possibly fool Kevin because I could give him a zombie, and the zombie engages in all these sensorimotor contingencies that completely satisfies his idea of squishiness and so on. And I know it's not feeling a thing because it's a zombie. And this zombie could actually be a robot that I program, right? I could have my robot that performs all sort of squishing, squeezing operations on different objects. I have a little classifier on top. That's this cognitive layer. I could argue, look, it performs all these actions, but it doesn't feel a thing.
Hang on, I've lost you a little bit there. Are we talking about fear or sponge squish softness?
No, I jumped out of fear.
Okay, so let's summarize then. You're saying, would it be possible to get a zombie who had all the sensorimotor dependencies with regard to softness, but did not feel the softness?
Right. So I was dealing with the issue of the verification, because with emotions you want to jump out of it as well, which I understand. But I was trying to push back a little bit and say, but wait. You could argue that specific lesions to the brain, right, like in the laminar nucleus of the thalamus, would leads to a loss of feel, right, of subjective experience. So that brings me then to this topic of the zombie, and I could actually build a zombie in the form of a robot. That was sort of how I was summarizing those steps. So the question would be, what would be missing in my zombie that I would build in the robots I have upstairs, right? With respect to your theory, how would you not be fooled by my zombie?
So, yeah, I mean, that's a really interesting question. Okay, but let's do it. I'm not really familiar enough with the anatomy of emotions to be able to argue or talk sensibly with you about it. So let's do what you were suggesting, namely apply it to softness.
Mm-hmm.
Okay,
sure,
so
that's fine.
So what would be a softness zombie? It would be somebody. Which would be the bit that you would excise out of his brain so that he would become a zombie in the case of softness feel?
Well,
what would it do? I mean, how would it affect the actual...
Right, so let's build a robot, okay? It's easier. So I have a robot. The robot has a hand. I have them upstairs, actually, like an iCup humanoid robot. It'll be squeezing stuff.
Yeah.
You show it objects, it will squeeze them.
Right.
And it will squeeze them, let's say, in a way that's fully consistent with how you have characterized this in humans, let's say. Now I could argue. And then in my control architecture, I need to sort of locate objects, grasp them, squeeze them, release them. I generate sensor feedback because I have sort of haptics on my fingertips, I have little sensors. And now I just classify these states. I have some classifier that now says, okay, hard, soft, and so on. It would satisfy roughly, I think, the theory of realizing the sensorimotor contingencies and classifying them. Those has this cognitive layer.
Now you need the bodilyness, grabbiness. You need the grabbiness.
So I would need the grabbiness. It would not have any sense of grabbiness because grabbing stuff is all it does and squeezing stuff, right?
No, you'd have to build a thing in such that if suddenly, as it was squeezing the sponge, a needle pricked into its finger, that its cognitive resources would be would be
some orienting that we can do. That's so some sort of exception detector.
Yeah.
Right? So that's an easy one. So what else is missing?
Well, it has the bodilyness. It has everything now.
Okay, so would you say this robot has feel?
Yes.
Okay, so that robot would have solved the qualia problem.
Yeah.
Okay, so then we're very close. That's cool. Okay, very good. That gives me hope. But so the other thing is then, if I could go to other aspects of feel, I could become psychotic, which is more difficult to do in a robot. So
before you've got me thinking here. The people listening to us may be a bit shocked, because we've just been talking about a robot and we built all this stuff in and now the robot feels.
Yeah.
But I submit to them who are listening to us that, this is what insects, for example, would you say that insects feel? Would you say that flies feel? Mice feel or slugs feel?
I have no problems with that.
Right. So it's really a matter of definition. And I'm saying that if you build, where you put the boundary between feeling and not feeling is just a matter of choice. And my tack on this is that if it has the qualities of sensory of bodilyness, insubordinance, etc., grabbiness, then it's very much like what we do. And so I would consider it to be sort of racist with regard to these other agents or animals to say that they do not feel.
Right. However, if I understand it correctly,
real experiences, but they also don't have a function. It's just one subset of the possible ways of interacting with the world that humans have.
Okay, so you're saying we should not pose these questions at this level, like what's the function of X?
Yeah. Well, not in this case anyway. I don't think life has a function. I don't think feel has a function. I don't think consciousness has a function because they're just words that describe the way we interact with the world.
We could
ask, why do we let's be more specific and say, why do we interact with the world in this way rather than that way? So for example, why do I interact with why am I conscious of the red light where I stop when I stop my car, rather than being not conscious of it? No, I don't know whether that's a meaningful question. Sometimes I am conscious of it. Sometimes I'm not conscious of it. If I'm talking to my fellow in the car. No,
but would you be willing to talk about the function of vision, let's say, or the function of having hands? would you be willing to consider that question? Also, that you would say, look, this really doesn't matter. That these functional questions or these more teleological
it's dangerous, isn't it?
I think they're essential. I think they're essential. It's certainly coupled with feel, but I didn't write your book, right? So
I think I understand. So you're saying one could say of humans that the function of having hands is that it will enable them to survive better, essentially.
Yeah, to also engage in certain interactions with certain objects, certain sizes, food handling, whatever, defense, God knows what.
Okay, so why not ask the same question for
exactly.
feel?
Yeah.
And I would say, what I say? I say, well, the real question is, when you say, the real question is, well, let's take red then, the feel of red. Why does red have a feel rather than not having a feel? What is the function of it having a feel rather than no feel?
Yeah, that's what I want to know.
If you really ask what you mean by red having a feel, what I said is what you really mean by red having a feeling rather than not having a feel is that it has this sensory presence. That's to say that it can attract your attention if it changes suddenly. It changes very much when you move your body around. Why are things that way rather than not being that way? You have me a bit stumped there. Because,
right. No, but it's interesting, right? Because apparently if we go from hands to red, there seems to be some strange transition. Okay. And so the question is, are we entering a regime of interrogation where we say, look, now we're here, we're fooling ourselves. Yeah. Here it doesn't matter, but below some boundary it does. And is it then gradual or is it some discrete transition?
So I admit I'm slightly stumped there, but while I think about it, let me ask you a question. What is the function of life? So do you think I mean, you went from hands to red and I was stumped. Now let's go from hands to life. Aren't you going to be stumped there?
No, because to me, life indeed has no function as such except reproduction.
But so why does So, but why?
That it maintains itself, right? In that sense. So I'm willing to.
But that's what we mean by life. That's not its function. It's part of what we mean by being alive is that it replicates, remains.
Well, you have agents that can be alive and don't replicate. They just don't.
Okay, well, that it maintains its function.
Yeah,
like memes.
Right.
Memes also maintain themselves.
Right.
So
no,
are they alive?
But I would search in that direction. I would not be stumped by it. I might make a massive mistake, but this is roughly where I would go with my answer. Right. And I think
with regard to life, you mean?
Yeah. Yeah.
So how could I do that with regard to red?
Exactly.
Good. Well, I'll have to think about this.
No, but there's an interesting challenge here, right?
Yeah.
So this is not necessarily also let's say a flaw in the theory. I think it is an interesting because what is nice is that what is actually powerful of what you're proposing. Now we can pose this question, okay, and we have a framework in which we can start to address it. And that's why I first tried to do it through the sensorimotor contingencies, but that might not be enough. I just don't know. But that's something we have to investigate. So now to finish up, I have two questions. So now you just published this book, also sort of expressing a long tradition of work, including co-inventing or inventing change blindness as a phenomenon, which has given rise to a large number of experiments. So building on this experience also in different disciplines, different domains, now attacking this really hard problem of consciousness and qualia, what's the one law of Kevin O'Regan that we should keep in mind when we study mind, brain, and behavior?
Yeah, I would say it's this law of abandon reification. That would be my law. Abandon magical substances.
Okay, no more myth. Right. And then the second thing is, since we're doing science, we want to do predictions. And I would like to come visit you 5 years from now, wherever you are. And I just to annoy you, I want to say, look, 5 years back you made this prediction. Today I want to know whether it really came out. So what's this one prediction you really would like to make today?
I haven't thought about that. What prediction? I would really like to do more work on color, because I think I've really got a handle on color here, and it's very, very exciting. And also the sensory substitution work. I really think it should be possible to make more realistic sensory substitution devices, not so much for vision, for replacing vision, but perhaps for auditory perception.
Mm-hmm.
You know, people are using cochlear implants a lot as prostheses for deaf people. But I would have thought that it would be really possible to make an efficient, say, tactile prosthesis for deaf people.
Okay, that's your prediction. 5 years from now, we're going to have one.
Yeah, 10 years. 10 years.
No, I asked for 5.
5 years.
Okay.
That's a bit,
Okay, Kevin O'Regan, thank you very much for this interview.
And thank you, Paul. Very interesting.
The CSN podcast was produced by the Convergent Science Network of Biomimetics and Biohybrid Systems, a project funded by the European 7th Research Framework Programme. For more interviews, recorded lectures, or upcoming conferences in the field of biomimetics and biohybrid systems, go to csnnetwork.eu. And thank you for listening.